Hello, welcome again. We are solving some questions of strength of material. The topic is deflection. Question number 20 is consider the beam AB as shown in figure below. Part AC of the beam is rigid while part CB has flexor rigidity EI. Identify the correct combination of deflection at and B and bending moment at and A respectively. So this is your cantilever AB with part AC is rigid and CB is having flexibility here. Okay. So options are PL cube by 3EI, comma 2PL. Option B PL cube by 3I, comma PL. Option C 8PL cube by 3EI, comma 2PL. Option D 8PL cube by 3I, comma PL. Okay, so now the part AC, this part AC will behave like a fixed end. Okay, because it's because it is rigid. Okay, it will behave like a fixed end, and while calculating the reflection length AC will not be considered. Okay, because it is the part of fixed end. So the reflection is PLQ by 3I. So this is PLQ by 3EI. Okay, and the moment about the fixed end is P into 12. So answer is 2PL and PLQ by 3L. Option A is the right answer. Next, for linear elastic beam shown in the figure, the flexor rigidity EI is 718 to 1250 kilonewton meter square, where W is 10 kilonewton per meter. The vertical reaction RA is 50 kilonewton. The value of RA for W is equal to 1000 kilonewton per meter is option A 500 kilonewton, option B 525 kilonewton, option C 250 kilonewton, option D 75 kilonewton. So total load is WL, that is 10 into 5, that is 50 kilonewton. And when W is 10 kilonewton, so RA is 50 kilonewton. So it means there is a deflection of point B which is less than 6 mm. Okay, so so that's why there is no reaction at point B, and whole of the vertical downward weight is balanced by RA. Okay, and now when the when RA when this W is 10 W is 100 kilometer per meter, then there will be deflection at B which is more than which can be more than 6 mm if there is no support here, but the deflection is 60 to 6 mm. Okay, so deflection is 6 mm, so the deflection 6 mm is equal to deflection due to wall minus deflection due to RP. Deflection due to this wall, okay, and deflection due to reaction RP is net is equal to 6 mm. Okay, so this is your WL4 by 8EI. Due to UDL deflection is WL4 by 8EI, and due to RB the deflection is RBLQ by PI, and the net deflection is 6 mm. Okay, so this deflection is more than sorry, the deflection here is net deflection is 6 mm, and that 6 mm deflection is due to this load and this due to RB. Okay, so from this RB, taking RB in meter and taking as this LCM. Okay, so so that will be 6 into 10 minus 3 into 24 EI, and this will be 3 WL4 minus 8 RBL cube. So W now is 100 kilometer per meter, 100 kilometer per meter. Okay, so W is 100, so and EI is 718 was 781250. Okay, so putting these values, and L is uh, and L is 5 meter or 5. Okay, so putting these values we get RB is equal to 75 kilometers. Okay, now total now RB is 75 kilometers, and this WL is 100 to 5, and so subtracting the total vertical downward load from the from RB, we get, because total vertical upward load is RA and RB, RA plus RB, and total downward load is WL. So RA is just 500 minus 75, that is 425 kilometers. So RA is 425 kilometers. Answer is option B. So that is the deflection due to wall or uniform distributed load minus deflection due to RB. Okay. So that is 425 kilometers. Next, a horizontal beam ABC is loaded as shown in figure below. The distance of point of contact factor from end A in meter is dash 0.75 meter, 1 meter, 10 kilometer, and this is 40. So now let RB be the reaction here, and RA is the reaction here, and MA is the fixing moment. This is 10 kilometer, this is 0.75, this is 0.25. So EI using the equation of using Macaulay's method and taking x here, okay, so it will be 10 into x minus RB into x minus 0.25. So EI d square by dx here, 10x minus RB x minus 0.25. So integrating it will be EI dy by dx, 10x square by 2 minus RB x minus 0.25 square by 2 plus C1. EI y 10x 2 by 6 minus RB x minus 0.25 2 by 6 plus C1 x plus C2. So x is equal to 1 meter, means x is equal to 1 meter, means this fixed end. So at fixed end the slope and deflection are 0. So at x is equal to 1, slope is 0. So putting this quantity as 0, we get the value of C1 in terms of we get this equation. Sorry, we get this equation here dy by dx. Sorry, first of all putting the x deflection 0 at x equal to 1. So we'll get this equation. This is 10 by 6 minus RB 0.75 is 2 by 6 plus C1 plus C2. Okay. Now again putting here for the value from x is equal to 1, dy by dx is 0. So dy by dx is, this is 0. Sorry, this is 1. This is 1 minus 0.25 square 0.75 square by 2, and this is C1. So this is equation number 1 and this is equation number 2. So solving 1 and 2 we get solving sorry now third equation is also there. At the spot the deflection 0, so at x is equal to 0.25, y is equal to 0. So we get the third equation, that is C2 is equal to minus 0.26 0.25 C1. Now putting the value of C2 in 1, okay, so we get the value of C1 in terms of RB, that is equation number 4. Now solving, now we have equation 2 in terms of C1 and RB, and 4 in terms of C1 and RB. So now to equation 2 variables, so we can solve this equation. So from this RB comes out as 15 kilonewton. Okay, now taking moment, now we have to find out the point of contact vector. So taking the equation of moment is this 10x minus this. Okay, so putting the value of RB and finding the point of contact factor, that is 0.75. Then we